This question is taken from the ENGAA 2020 Section 2 paper, and it is question 2. So we read, a single wire has radius r equals 2 times 10 to the minus 4 meters, length L equals 15 meters, resistivity ρ equals 4.8 times 10 to the minus 7 ohm meters. 12 strands of wires are connected in parallel to make a cable. What is the cable's resistance? So let's try and draw the setup of these wires. So we have 12 of these wires in parallel. So we have 12 of these areas, and that means using the equation between resistance and resistivity, we have each area multiplied by 12 gives the effective area for the current to travel through if we were to add this to a circuit. So the resistance would be R equals the row times the length over the area times 12. So essentially the effective area is 12A. So if we put these numbers in, we get 4.8 times 10 to the minus 7 from the resistivity times the length divided by 12 times the area, where I've used pi r squared as it is a circular cross-section. So cancelling some numbers out, we can do 4.8 over 4 is 1.2, and then the 10 to the minus 7 over 10 to the minus 8 gives you a 10 to the 1. Then if we notice we have a 1.2 and a 10, then we can cancel that out with the 12. So all that we are left with is 15 over pi as a resistance. So the technique used here, as they were added in parallel, meant that the area increased by that factor. If we were to add them in series, then that means that we have a constant area, but the length has increased by 12. So a longer wire would have a larger resistance because there's more of an obstacle essentially for the current to get through. Whereas having more areas, more pathways, means that the resistance is effectively lower by having more area in this case. So that's how, as well, if you wanted to do this by connecting it to a circuit and then working out the resistance of each one, and then in parallel using the 1 over R plus 1 over R plus 1 over R for each one, then you effectively get 12 over R, and then the inverse of this gives you R over 12. So that's why having 12 times the area gives you an effective resistance of a 12th of the resistance of one of the strands of wire on their own.